Here I have a yellow fluorescent highlighter, and I'm going to use uh, this tool to pull the back cap off the highlighter. I'm going to remove the reservoir that contains the ink and use this tool to squeeze it to remove the ink. Okay, let's remove the cap. There we go. Put it in a Ziploc bag. Squeeze some of it with the fingers. You can use the tool. I'm going to clamp that so it's out of the way. There we have some of the ink out of the reservoir. I clipped the corner of the bag and poured the ink into a small vial. And I used a syringe with a blunt needle to deposit 1/10 milliliter into a vial to verify that my method of extracting the dye from the ink will work. Yes, this dye looks transparent. If it looked milky, the method probably would not work. This dye is interesting both because it fluoresces under ultraviolet light, but it also fluoresces under blue light. What I'll be using to remove the dye from the ink is 99% isopropyl alcohol. Using a different dispensing syringe with a blunt tip, I added 1 milliliter of the 99% isopropyl alcohol. You can see it's still a yellow color, but if we shine a laser pointer in it, the beam shows up. If it was transparent, it would have went straight through. Still glows a little bit in the ultraviolet, and maybe a little bit in the blue, but it definitely isn't as strong as it was. I've added 2 milliliters of the isopropyl alcohol, and the laser pointer, you can see reflecting off of particles. And if we use an ultraviolet light, we kind of get a pale blue or cyan color. And if we use a blue light, we don't appear to be getting fluorescence anymore. I added another milliliter of alcohol to the small value, and then I used 1 milliliter of ink and 30 milliliters of alcohol in a larger container. This one is sat for over an hour and a half. This one I just added the third 10 milliliter not too long ago, so it's still turbid. If we shine a white light on them, You can see the original ink is green. This one isn't showing any fluorescence, and neither is this one. If we shine a blue light on it, we get a lot of fluorescence from that one. Not really fluorescent from this one, and neither do we get it from this one. Now if I shine ultraviolet light, we get fluorescence. It's fluorescing a very pale blue, and this one is also fluorescing a pale blue. Now if you look, we have a little bit of precipitate at the bottom of the container, yellow precipitate. Here we have a lot more formed. I believe that is the dye. Yeah, I put a little bit of the precipitate on a paper towel, and under white light, looks like this. Under blue light, it looks like this. It's dark in the center with a little line of greenish or yellowish around it, and then it's pinkish. Under UV, it's dark in the center, greenish. Put a little piece of the paper towel with the material on it in water, distilled water, and this is a white light emitting diode flashlight. It's got a pale green color. Through blue, it's bright green fluorescence, and ultraviolet, it also is a bright green fluorescence. I took a little bit of the precipitate, dissolved it in distilled water, and it was green, and then I added some isopropyl alcohol to it, and it went clear. The laser pointer goes straight through it. There's a slight showing of the beam with white light emitting diode. With a blue light, there's a sort of looks like a slight pinkish color to it. And ultraviolet light, it glows that pale blue, but it hasn't actually precipitated probably large enough particles to show the laser pointer.